Hello, I'm Philip Stoughton for ScoopTalk. I'm here at Apex 2017 in San Diego, and I'm joined by three guests to discuss the topic of voiding. We have David from Hella, we have Mary Beth from KIC, and we have Chris from Indium. Thanks for joining me, guys. I just wanted to kind of set the scene and understand what's important here in terms of what the problem is and what's acceptable in terms of voiding. I guess some voiding is almost inevitable. David, maybe I can start from you.
Sure.
With you on that question.
There's really two areas of concern. One of them is the semiconductor industry, and they have very strict rules. They need to be below 1% for power die, for LED, and that's a different world. In surface mount, the difference is considerable. They'll typically operate uncontrolled around 30 to 25%, but if people could be below 10%, they'd be much happier.
Yeah, does that fit with what you're hearing from customers, Mary Beth?
And I think it even gets a little bit more narrow as well, because you have issues with voiding when it comes to VGAs and some other components, but then when it gets to bottom terminated components, that's even another type of voiding problem. And there aren't really specs on that, so different companies have different goals that they'd like to achieve, but they're also sort of tied to the equipment and what they're given by the customers to build, or the OEMs, how they're designing it as well.
Yeah, and Chris, from your point of view, do you have specs? Do you have specs that say this is going to avoid this sort of particular?
Well, we really don't have any specs, but our customers, they're the ones that are setting the specs. And along the lines of Mary Beth was saying, it even goes even narrower into which industries really are focused on voiding. It is really the industrial industry, the automotive industry,
That's true.
and the high-rel type applications, aerospace in the middle. So they're the ones that are really pushing for lower and lower voiding specs.
Yeah, and let's be clear on it. If there's a void there, or if there's too much void in there, this is a joint that will fail at some point in the field in a hostile environment, correct?
See, that's the interesting point. With a bottom terminated component, what people have shown is that you could be over 50% void, and it's probably not going to fail. It is so robust. So it's not a solder failure that they worried about. It's the die failing because of a hot spot.
Right. Okay.
It's interesting also because I think a lot of people don't realize, why are they concerned about voiding? They hear that voiding is a problem, but the long-term effect, right? What is that, and is it important, right? So there's sometimes they're trying to eliminate a problem that may not really be a problem.
Exactly.
Yeah, I think that's always a tendency we have in the industry. We have to figure out what the end game is before we start that development process. So having understood the problem, what's the solution? Let's start from a hardware point of view, and then we can discuss maybe the solder and then the control as to how we understand it.
And I think that an integrated solution is always best, but what we offer on the hardware side, we would refer to as a process sledgehammer. When you use a vacuum machine, you'll go from 20, 25, 30% down to under 1%.
Right.
But the downside is that the machine is expensive. It takes a lot of equipment to put a vacuum system inside a continuous oven. And we have another alternative to use ultrasonic or sonic vibration, less expensive, but again, it's involved.
Yeah, it's making the process complex. And as you said, when we talked about scaling the problem, you need to understand what you're trying to achieve.
Exactly.
And as you say, the sledgehammer approach of 1%. From a materials point of view, I guess you're constantly developing solutions.
Absolutely. We're really focused on voiding right now because we see it as the number one concern within the industry. So we have two unique products that we're really driving into the market, and it's 8.9 HF and Indium 10.1. But we do have further formulations that are in development right now to reduce voiding from levels of 25 to 30% down to the 10%. So that maybe Dave and Heller and the oven technologies can bring it from 1% even down further to less than 5, or less than 0.5, less than 0.3.
Yeah, so bring it down to what they need. Knowledge is power in this case. Mary Beth, how do you get that control information? How do you understand what the potential issues are? What can you do from a control point of view?
So I think a lot of the solutions that both of them have are solutions either you have to make a decision, a very educated decision, and this is what I'm going to do to avoid the problem, or if they're changing a material, then how does that affect the rest of their builds, the rest of the products that they're building? So oftentimes a profile can be the solution. It's a fast solution. I can make some changes to my profile. I can do some changes to the oven and see the immediate results. So oftentimes that is kind of an on-the-fly solution to reduce it, or at least get on the path to doing so. So, trying to optimize for individual products rather than just the solder paste, having the ability to look at the whole product as it's being built, address the solder paste requirements as well as the component requirements is quite important.
Yeah, and if I put myself in the position of the manufacturer, I want all three of you guys to be working together to resolve that problem. And in an ideal world, I'd probably get you in my office at the same time and say, look, this is what's happening, this is what we're doing. How can you guys fix it between you? Is that collaboration going on throughout the industry? Are you working with all of the solder suppliers, all of the oven suppliers, all of the software suppliers? Is there a good relationship within the industry to get those results? David?
Yeah, I would say in particular, we collaborate very well with Indium in particular. On the semicon side, there's very close work. There are not a lot of customers, not a lot of applications. Indium's in a lot of them, and
That's true.
we do collaborate because when we find something that works, we let them know, and vice versa.
Yeah, and it's finding a formula, isn't it? That's not just.
And these are not
element.
hardware or chemical solutions. You got to work together.
Yeah, absolutely. From your point of view, Mary Beth, when you're looking at the overall strategy, are you finding that collaboration and that sharing of data, which is equally important?
See, and I think that's the most important part, is as everyone is doing research on it, is to make it available and share it, because, for each customer to start to reinvent the wheel, that's crazy.
Yeah.
So I know personally when I started looking into this, I did a lot of research, and I know you've done a lot of papers on it, and David, you've presented some papers on it as well. So I think it's important that people do the research, do the work up front.
Yeah.
They have a much faster solution then.
Yeah.
And I really think it's the entire process all rolled into one, and that's what Indium tries to do, is really research the entire process. Not just our materials, but look at the reflow profile, look at stencil design, look at profiling with the KIC products, and roll it all into one. So it is very important that we collaborate as an industry to bring a full solution together.
Yeah, and that's interesting because then you've got the opportunity to co-present, and I know you've done that at a number of occasions. How responsive has the audience been? Has it been one of those presentations where you finish, there's a ripple of applause and everybody goes home, or is there a good Q&A at the end where they really want to gain the knowledge? Mary Beth?
I think the reaction is good because people do want to learn. They know that they have a problem, or if they're going to be changing to some new products in the future that they anticipate they may have a problem. The research that you did with stencils I thought was very important also for the industry, because people didn't think at looking at that as a possible solution. So I find the questions to be broad, and they are searching for solutions.
Yeah. David?
Yeah, I would absolutely agree. Just came back from a paper a few minutes ago, and the attendance was good. A lot of people, they need to go home and solve problems next week. So they're very eager to learn about what other people are doing.
And quantify those problems and figure out a path where they can work with various people.
I get questions about vacuum ovens all the time. All the time.
Yeah, and you can fill them and pass them to each other. Guys, thanks very much for sitting down with me. Fascinating conversation, and good to see a whole group of companies collaborating to make that process better. That's very, very encouraging.
Thank you.
Thanks for
Thank
that.
you.
Pleasure.